Today on the presentation, I will present about the findings for mini project number 1 and number 2. So a few points are going to be discussed here. We have section 1, which is going to cover for mini project number 1, and also section 2, which is going to cover for uh, mini project number 2 that will be discussed further on. Okay, so before that, my name is Audrizak and I'm going to be the speaker for today. Okay, so on section 1, it's going to be covered for mini project number 1, and points of discussion will be introduced during the discussion. But one of the points would be schematic diagram. It is going to be discussed together with utilities and identification. So for the introduction to the company that we have chosen, I have chosen, it's Unical Mindset. It's situated in Alugaja, Melaka. So the nature of the business is a university which focuses on higher education on many chemical fields. Thus, it is equipped with many laboratories and workshops, which emphasizes on training and hands-on experience. So the focus of the campus will be on the pilot plant. So a couple pictures at the site is me at the boiler room and during and water treatment during Mrs. Zamzur explaining about the process. Again, now for the business operation, I'm going to be discussing about organization structure. We only have 4 people here, so that's the size of the business operation. The hierarchy, it actually starts from the dean, but we exclude her because we're only going to focus on the pilot plant. So the organization is quite small, as I said. The top of the organization, it starts with Dr. Mohammad Razali, which is the head of section for process. So his prime role is to lead, manage, and develop his department. But for the pilot plan, he is responsible for approval of technical activities. Then we have our lab manager, which is Dr. Amin Zafon. Main duties, it includes overseeing daily operation, scheduling and tasks, prioritizing. So he will also cover for technical advisors, proposal of improvements, any upgrades and maintenance schedule. Then we have our technical teams, TS Mohammad Zamzuri and also Mr. Mohammad Fairuz. Their responsibility in the pilot plan includes operating and troubleshooting experimental projects by students, and also performing general housekeeping to keep the equipments in good condition. But most importantly, they will be performing the hands-on maintenance and servicing. As we can see here, the pilot plan, it covers for 15 different processes for the students. Most exercises, it focuses on the refining of crude palm oil into the final product. And one of the process, this is one of the PID obtained from the pilot plan, it's for dry fractionation. Now for the utilities identification and also schematic diagram. For the steam boiler, right, the first utility is the steam boiler. So main objective is to produce steam by heating water beyond the boiling point. And the equipment will be used to supply the steam to a few sections of the pilot plant, including dry fractionation and also the physical refining. And here are the equipment plates for the boiler. We have 10-bar boiler and also a 6-bar boiler. The difference between both is the amount of steam that is going to be produced. So usually we specify it at as 10 bar and also 6 bar. And the output for the 10 bar is 160 kilograms per hour, and the 6 bar is around 37 kilograms per hour. So this is one of the produced schematic diagram. The top section over here is a softener, which it turns the water feed. It removes the sediment and contaminants, and also it corrects the pH balance for the water. And after the softening process, it's gonna be fed into the boiler room, one into the 10 bar and the other one into 6 bar. The 6 bar has a built-in reservoir for both water holding and also heating, right? For But for the 10 bar, as we can see over here, we have an external reservoir for holding the water, and another reservoir inside is for the heating, right? So any lines from the overflow, the condense, the drain, it's going to go back into the water tank. And also we can see that there is going to be a discharge, right? There is going to be a discharge separate line. So the 6 bar is going to go into a hot room, which is also a storage room for the semi-solid oils. And 10 bar is going to go into the refinery and any other processes that needs 10 bar. Okay, now for the water treatment, the second utility. The main function for the water treatment is to treat any water before being discharged to drains or being used for other activities. Here we can see the chemical treatment tank and a few other pictures that were taken for the water treatment. We have the biological tank, and then we have the filter press and also the clarifier. You can see there's going to be a holding tank, also a multimedia filter at the end. Okay, now for the schematic diagram. First of all the pumps P1, P2, P3 is an AODD pump which operates with compressed air. So the first tank over here, AT, is the aeration tank. It adds oxygen to the water to stimulate the growth of bacteria and microorganisms that will help convert any organic contaminants into inorganic substances, right? Then the water is going to be fed into the chemical treatment tank, CT. So the focus is to destabilize the particle inside the wastewater so they aggregate during flocculation. So coagulants are going to be added, which is positively charged, and they will reduce the charge of the overall sludge inside. It will form into larger groups, and then this will be removed with sedimentation. Then over here we have the filter press. It's fairly straightforward. It's only to separate the solid from the water, and then it's going to go directly into holding tank number 1. So from the holding tank, it's going to be pumped into the biological tank. This treatment, it relies on using bacteria or any other microorganism to break down organic waste. So the pH of the water in the biological tank is already at an acceptable level, but we have to further treat the water. So it's going to be transferred via overflow into the clarifier. So clarifier is basically sedimentation, right? Where the particles, it will settle out against the barrier. And the bottom section over here is where the sludge is going to be coming out, and it's going to be fed into other processes of the water treatment. So also from the clarifier, it's going to be going to another holding tank via overflow, and from the overflow, from the holding tank T2, it's going to be pumped into the multimedia filter. So as the name implies, it will filter out any remaining contaminants that are removable by filter, and then the water is going to be discharged or used for any other purposes. So for this part, it's quite simple, only consists of a few equipments. The function for this utility is to produce compressed air at around 8 bar, right? So we can see here it's an easy setup. The main equipment, as shown previously, was this one, the compressor. And then we have a holding vessel, we have a dryer, and also we have filters. So that means basically only 4 equipments, but we have 2 filters. Okay, so for the schematic diagram, fairly straightforward. We have the compressor. It will siphon any air from outside and compress it before going into the vessel. So the vessel, it's going to be in closed state before the air is going to be usable up until 8 bar, and then it's going to be opened. This is the bypass, usually closed. So the air is going to go through a filter, and then the filter will remove any solids or any unwanted contaminants. And then the air is going to go through a dryer, which will remove any moisture, and then another filter, and then directly to the plant. So now it's the maintenance plan regime by the company, right? So the maintenance policy for the company is based off the maintenance plan, and I have a sample here taken from the maintenance program by the pilot plant. This is done for the steam boiler. As we can see, it's performed biannually every 6 months, and this was taken back in the year 2020. A few items can be identified over here, like switching on the boiler, inspecting the water level, inspecting the installation and connection, and then inspecting service gas meter, and then going into the element, and then checking for the electric panel, and then just some cleanliness steps, which is 5S. And for the year 2020, around March and 9, that's a gap of 6 months biannually. And then this here is one of the failure found by using the maintenance policy, right? So they found the heating element damage around February of this year, 2021. This will be discussed in the next section. Okay, now for section number 2, the basic findings are already discussed in the previous section. So this section is going to focus on the issues, the factors contributing to the issues, and the effects to the operation, and also a monitoring regime. Okay, so the frequently occurring issue, one issue was the heating element failure. It's the most prominent issue that often occurs in the power plant. So yeah, it's also called burnout of the element, and this is it. The factors depends on the equipment age, the environment, and also the usage, right? So the extent of damage, how damaged it will be, it depends on what operation and how the operation is was run. So as I've shown earlier, as reported from the preventive maintenance plan for 2021, it was seen that during the routine biannual inspection, the element was inspected to be damaged. So here, as we can see in the terminal for the 10 bar element, it's melted, and also for the 6 bar, the wires have melted. And then what are the factors that may cause the issue? So one is increased resistance. So that's by technical, right? We have to understand that high resistance, it produces higher current, and high current means it's gonna produce a higher temperature. So yeah, so theory for the issue, we have to understand that we are dealing with an equipment that produces heat. So that one thing should be considered. All heating element has its own operation rating, right? So when the protective material on the heating element is operated at prolonged time, oxidation it may occur, which will reduce oxidation resistance. Hence, it will induce more oxidation, or as we call it, scaling on the external surface of the element. Right. So when oxidation occurs, the resistance inside the element also increase. Hence, we can see over here the relationship of power to the current and resistance. Power is the product for current and resistance. So if we rearrange the equation actually and make the current as the subject while we maintain the power, right? So that means if higher resistance, it's basically gonna increase the current, and then higher current will increase the temperature. So what are the effects on the operation? Right. So two of the effects is yeah, logically, if the steam supply drops due to lack of heating, the processes inside of the pilot plant will not receive any supply of steam. this will result in the students not having they cannot do any activities or experimental activities. And also for the downtime, right? If we neglect the issue and we respond slowly to element failure, it may pose risk of pilot plant shutdown, because this is a corrective policy. We don't want to do any unwanted emergency maintenance or shutdowns. So yeah, one of the main processes that are going to be affected is like the bleaching and deodorizing unit. So first of all, like the deodorizing unit, uh, its principle is to remove contamination from oil and also recover the oil from the filter with steam, right? So if we have failure of the steam supply, this translates to failure of oil recovery, and also it lowers the quality of the product that will be produced, because the free fatty acid is not fully reduced during deodorization. And lastly is, if there is no steam, then the product, which is our BDPO, is not going to be deodorized. Hence, we are going to have a low quality product, or basically we failed an experiment for the students. Okay, now for the monitoring regime, uh, we have uh, we have to understand about the frequency of the failure for the pilot plant. We identified the frequency from previous records that it occurs during couple months around February and August of the years, and this occurred during peak study months where students utilize the pilot plant for experiments and exercises. And then we have preventive and predictive maintenance, right? It's just a comparison for the selection. Corrective maintenance was excluded from the selection because we don't want any downtime for maintenance or servicing, right? So for the two policies over here, although predictive, it seems like it's a viable selection based on the data for the occurrence rate of failure per month. One factor that has to be considered is the cost of deploying this type of policy, right? So one study, it reported that predictive maintenance is the highest usage of capital when compared to corrective, preventive, and also predictive. So here we have a few things to consider for the regime, right? We have visual inspection. Uh, we have to do some water safety control inspection, and then we also have to inspect the element. And lastly, for the internal inspection, it depends on the previous considerations. If it passes visual inspection and water control or water safety control, then it's gonna be performed like every quarterly, right? So every 3 months. All right. So this is the monitoring regime that I've considered. First one is visual inspection. We have to check for any leakage around the piping of the steam and water feed valves and also fitting, right? So before any repairs, we have to fully shut down the equipment and also rectify the issue before operating the equipment, and the frequency is weekly. For the safety control inspection, we also have to check for the pump, the level, and also for the evaporation, it's based on the level level inspection. So this is performed weekly. And then element care and inspection, this should be done monthly, right? So this is inclusive of the visual inspection. If we see any burnings on the wires or any damage on the element terminal, then we have to do internal inspection. And then a multimeter should also be used to check the resistance of the element, right? And lastly is internal inspection. So internal inspection is subjected to different conditions, like from the previous consideration, right? So if the element is removed, so internal inspection should be performed. But if there is no removal, a monthly basis inspection should be considered, depending on the usage of the equipment. And then lastly, if the visual inspection is satisfactory, if all the safety checks are satisfactory, then a 3-month basis could be considered. So that's about it for the presentation. Thank you.